Let us now look at a different kind of graph. Just like the distance time graphs, time is represented along the x-axis. Along the y-axis though, we plot velocity. What we will get here is the velocity time graph. It's velocity versus time to be precise. If we have a vehicle traveling at a constant velocity, what will the plotted line look like? Let's assume the vehicle has a constant velocity of 10 meters per second. So this is 10 meters per second, and we draw a line which is parallel to the x-axis. At any moment in time, what we see is the constant velocity the vehicle is traveling in. Now let us try and recollect what was product of velocity and time. I'm sure you remember that the product of speed and time is distance. But velocity is a vector quantity. What is the product of velocity and time then? It'll be distance with direction, which is referred to as displacement. So if the vehicle travels at 10 meters per second for 4 seconds, the displacement will be 40 meters. 10 times 4 is 40. Let us look at this graph again. Let's look at this area which covers 4 seconds and draw lines up to the plotted line. What we see here is a rectangle. Let the length on top be AB and the one at the bottom be CD. So we know that the velocity is constant at 10 meters per second. And here we can see that the time period we have chosen is 4 seconds. The displacement we calculated here was 10 meters per second times 4 seconds, which is 40 meters. And what is the area of this shaded region? The area of a rectangle is always equal to the product of its length and breadth. It'll be 10 times 4, which is also 40 meters. AC times CD equals the area of the shaded region. AC is nothing but the velocity, and CD is the time taken, which will equal T2 minus T1. So what can we conclude? We can say that the area enclosed by the velocity time graph and the time axis will give us the magnitude of the displacement. The area basically gives us the distance the vehicle has covered. Let me repeat this point as it's really important. The product of velocity and time will give us the displacement, and this area will give us the magnitude of this displacement, which is the distance. What if the vehicle was not at a constant velocity? What if it was uniformly accelerating? How would this graph work? Would it work at all? We see that in the next part of the video.